In this example, we have been asked to find the inverse of the one-to-one function f of x equals x plus 1 all over x minus 7. It has also asked me to give the domain and the range of the original function and the inverse function. The first thing I'm going to do here is I'm actually going to graph the function using my graphing calculator. So go to y equals. If you have something there, clear it out. Make sure that you use parentheses when you're entering this in our calculator. So y1 should be entered as parentheses x plus 1 divide by parentheses x minus 7. Anytime you have a fractional or rational type expression, you need to make sure to put parentheses around the numerator and the denominator. So I'll do parentheses x plus 1, close parentheses, divided by, open parentheses, x minus 7, close parentheses. I'm going to try this in a standard window, so do zoom, and then zoom standard, and then there's my graph. Now, I'm going to write something down that we're going to learn later on. This function, as it's written originally as x plus 1 over x minus 7, we know has a problem when x is equal to 7 because that makes the denominator 0. So in other words, we know that x is 7 is not in the domain of my original function. We call x equals 7 a vertical asymptote. Later, we will learn that an asymptote is a line that our graph gets drawn towards, but in this case cannot touch. Another thing that we will learn later about this graph is it has what we call horizontal asymptote, in this case at the coefficients that are in front of the x values. So because it's a horizontal asymptote, it would be y equals 1 over 1 would be 1. So y equals 1 is a horizontal asymptote for this particular function. Now, neither of those two things are things that I would expect you to necessarily know at this point, okay? But now that I've told you for this particular function, you can be looking for them. Your vertical asymptote here occurs at the value that would make the bottom 0, and then in this case the horizontal asymptote occurs at the understood coefficients on the two x values. So when we graph this, so sketching our graph, at 7 we would draw an imaginary type of line, meaning that our graph is going to get close to that but can't touch it. And then at 1 we're going to do the same sort of thing, drawing a dotted line, meaning that our graph can get close to this but cannot touch it. Looking at our graphing calculator, we can see what our function does. It kind of forms a C-shaped type graph over here, and then it comes from above, and it actually kind of looks like it goes down through 0 and then goes down and loops below. Okay, so there's the basic idea for the graph of the function. Okay, on here, let's answer the question about the domain and range of f. So if we wanted the domain of the function f, which is what we have graphed, it would be everything except x is 7. So it would be negative infinity to 7. Use a parenthesis to leave the 7 out, and then union 7 to infinity. The range of f, I would think that in this case we would need to know that that horizontal asymptote occurs at 1. We can see from our graph on our calculator that it looks like we approach some value over here, but we can't tell real well on our calculator what that value is. And so we need that prior knowledge that we have a horizontal asymptote of 1. The range then is everything except that value 1. So you would do negative infinity to 1, leave it out using a parenthesis, and then union parenthesis 1 to infinity. Now, knowing that, even though we don't have the graph and we have not been asked to graph the inverse, we can then tell the domain and range of the inverse. Okay, so the domain of f inverse would be the same as the range of the original. So that would be negative infinity to 1, union 1 to infinity. And then the range of f inverse would be the same as the domain of the original. So negative infinity to 7, union 7 to infinity. Okay, now going back up to our question, I'm going to minimize the calculator. It then wants me to find the actual inverse of this function, so the actual equation that would represent the inverse. So let's go down and do that. So finding the inverse equation. Okay, to do that, I first want to write down what my original function was. The original function is f of x equals x plus 1 over x minus 7. In place of the f of x, I need to rewrite it as y. So y equals x plus 1 over x minus 7. And then actually finding the inverse, I know what I need to do is invert the x's and the y's, or switch the x's and the y's. So where there was a y, put an x, and where there was an x, put a y. Now this is a trickier problem than we've looked at before. We now need to solve for y. Because it's a fractional type thing, we want to use the idea of using the LCD. The LCD would be y minus 7 over 1. And so we want to multiply both sides by that value. So y minus 7 over 1 times x equals y minus 7 over 1 times y plus 1 over y minus 7. The reason that we want to do that is to get the y minus 7 out of the denominator on the right side. We see here that the y minus 7's would cancel. On the left, the y minus 7 is put over 1, but we really don't need it. And so here, all that we need to do is distribute the x. So we would have xy minus 7x equals, and then on the right-hand side, y plus 1. So using this LCD gets the y minus 7 out of the denominator on the right-hand side, and also leaves us with an expression or an equation that is not a fraction. Now what I need to do is keep in mind that I'm solving for y. There are y's on both the left and right side. I need to get all my y's to the left and anything that does not have y to the right. So essentially here I'm going to move this y to the left, I would make it negative, and then I would move this negative 7x to the right and make it positive. So xy minus y equals positive 7x plus 1. Now I have the y's on the same side of the equation. I need to solve for y. Since there are two y's, factor the y out. So I would factor y out, I'd be left with an x, and then a minus 1 equals 7x plus 1. Now finally, to solve, I would divide by my x minus 1. So I'd have y equals 7x plus 1 over x minus 1. This is my inverse, so I need to switch my notation and say f inverse of x equals 7x plus 1 over x minus 1. And I have my formula for the inverse.